Okay, this is part one of several videos where I'm looking at the giant picture for people, where I'm not problem solving, I am just explaining how things are, okay, and I'm trying to focus that for the study guide, for the chapter. Okay, so in chapter 8, that's where we're going to start. We're going to oxidation numbers and formulas. The first question is, what's an oxidation number? Okay, what is the oxidation number? Well, the oxidation number, it is the positive or negative charge. Okay, it is the positive or negative charge for, it could be an atom, okay, or maybe a group of atoms. Okay? So an oxidation number, it's a positive or negative charge. It could apply to one atom or a group of atoms. So an example, what do I mean by that? Okay, well, we can talk about, here's hydrogen and here's chlorine. Okay? When we look at a group of atoms, we call them polyatomic ions. So in other words, it's a group of atoms together, and take all their individual charges, you squeeze it together to get one final charge, because that's the whole thing. So what would be some examples of polyatomic ions? Well, some examples would be like NH4, that's a plus, that's called ammonium, all right? That's one example. Another example would be SO3 with a -2. That's called a sulfate ion, okay? You'd say, but wait a minute, what's up with the plus and the minus? I don't get that. What's happening? Well, remember the idea, okay? How do we get these oxidation numbers? Okay? Atoms lose or gain electrons. That's the key. Atoms lose or gain electrons. That's the key, guys. Okay? Let's see if I can make this a little bit larger. There we go. So atoms either lose or gain electrons. That's the idea. But then the question is, well, why? Why would it do such a thing like this? Okay? Why? Why would atoms bother to give up electrons or pick up electrons or whatever? One word, a one-word answer. It is about stability. Stability. Some atoms, in order for them to be stable, they got to get rid of electrons, like sodium with its +1. Other atoms, like chlorine, they're more stable when they grab an electron. It's all about stability. Now, things like helium and neon and argon, they're the noble gases. They don't need to lose electrons. They don't need to pick up electrons. So it's all good. So that's the basic idea behind oxidation and why we see the oxidation numbers that are happening, okay? Now, can we have, as I'm going to move on to the next thing, so that's the idea behind the oxidation numbers, okay? Now, let's take a look at formulas for a moment. So we're going to look at formulas, and, well, Canu, what do we mean by formulas? Well, when we're talking formulas, we're talking about things like NaCl, H2O, CO2. Those are what we were called by formulas. Now, the thing about the formulas is we need a total charge, okay? A total charge equaling 0. If it's 0, guys, that means it's balanced inside a formula. Okay? That's what we mean by that. If the total charge is 0, the formula is balanced. Okay? So what does that mean? Well, a fast example is something like a formula, okay, and we're going to connect the balance to it. That's why I'm doing it with boxes and arrows and lines. Okay, so let's look at an example. We have Na with a positive charge because it loses an electron, and Cl with a minus charge because it picks up an electron. Okay, so that's what we have. We have that, and they combine. Okay, we'll talk later about how they combine, and then we end up getting NaCl with a 0 charge. Okay, and it's balanced. Yay! That's the idea. It's balanced. Okay, so other than that, that's the whole point. That's pretty much a good point about formulas. Let's move on here for a moment because you know what? There's different variations of formulas. Okay, so when we talk about something like iron 2 chloride. What? Huh? Hey? Huh? All right. Let's take a look at this for a moment. This right here, this is iron with a +2 charge. And if you were to look on the ion chart that I'll give you guys, you know, for the exam, you're going to say, but wait a minute, there's iron with a +3 charge, okay, and there's iron with a +2 charge. How am I going to know the difference in the formula? That's where the math comes in. And you're going to have to balance that out, okay? And balancing out formulas, that's in another video. But the Roman numeral, that's the key thing. The Roman numeral tells us what's the positive charge on our ion. So, for example, if I say iron 3, that means it's Fe with a 3, a positive 3 charge to it. Okay? That's what we mean by it. So that's what those Roman numerals are for. The Roman numeral tells you the positive charge to it. Okay? Let's go back up a little bit and look at iron 2 chloride. So I have an iron with a +2, and I have the chloride that has a -1 charge to it. Now if I add those up together as FeCl, I am going to have a -1 charge to it. Because the idea about balancing needs to be a 0. So how am I going to do that? Well, what number does 2 and 1 go into evenly? 2, okay. I already got a 2 on this side. I need 2 of these. Okay. So in order to balance it, so this is not balanced. That's where I've got my sad face on. And over here, FeCl2, it's a happy face because it is balanced. Because I have my +2 charge for my iron. I have a -2 charge because I got 2 chlorines, and each one is a -1 charge to it, huh? So that's what's going on. That's what's going on. So this is a quick balancing thing. There are my balancing videos, okay, that I go into it, but this is just a very quick thing here. Okay, a couple of other things. What about the funny little dot? What happens when you got CuSO4 dot 5H2O? Now notice this is a big dot. It's not a little period. It's not a little cute little decimal like you have in math. This is a big dot. It's huge. Well, what is that dot telling us? 1 this compound is a hydrate. That's the first thing. That means water has talked and hooked up with the CuSO4. Now in this case here, we got 5 of them. All right? Now, I'm going to go ahead and give you the formula, the name of the thing. It is, in fact, copper 2, because it's a +2 charge, okay, sulfate. Then the 5 comes in, and that's when you have those prefixes, okay? Pentahydrate. So copper 2 sulfate pentahydrate. Okay? Penta meaning 5, like pentagon, pentagram, okay? That kind of thing. Okay? Let me check. Did I cover everything on here? Yep. Oh, symbols meaning in a chemical equation. All right. So let me wrap this up here. Okay? So when they talk about symbols in the chemical equation, you have those symbols in the notes that show you things. For example, the arrow, this should be results in. That would be an example of that. If we have here a little triangle, that means add heat. Okay? That means add heat. So then after that, guys, we have, oh gosh, what were some of the other little cute ones that we had? I'm trying to think. Oh yeah, states of formation. Okay, this is iron as a solid. This is iron as a liquid. Okay, the S, the L. Okay. The AQ stands for aqueous. You hear the word aqueous meaning full of water. In other words, it's a solution. And usually you're not going to get iron as a liquid because it is really hot, hot, hot. Kind of like my YouTube career. Okay, I killed myself. So we got solid, liquid, iron, and then the last thing here, okay, G stands for gas. So those are your basic states of matter when we're looking at a chemical equation there. So S is for solid, L is for liquid, AQ is aqueous, it's a solution. So when we say a solution, usually means it's mixed up in water. Okay, and then here we have iron as a gas, which that doesn't exist, not really. Okay, all right, ladies and gentlemen, I hope that this will benefit you. We'll just take a quick look and everything. So this is all of here, just looking. We talked about the idea of oxidation numbers. What do they mean? We talked about the idea of formulas, that they're supposed to be balanced. Okay, and then iron 2 to chloride, we talked about the Roman numeral. What does that mean? What does the 2? What does the 3 mean? And then we also looked at what does the little dot mean, the hydrate. Okay, and then we looked at some, but not all, of the symbols in chemistry. I covered a couple of main ones with you, and then the states of matter for you guys. Okay, hey, I hope this benefited you. All right, and this is Grandmaster C tuning out. Stay tuned.